Hi there. Imagine this. It's 2019, and your company gets hired by a promising startup. You and your team build what's essentially an Airbnb for fashion, a high fashion rental platform. To prepare for fundraising, they bring in a finance expert to dig into the numbers. Suddenly, your role shifts. On top of building new app features, you're working alongside the finance expert, helping her understand the product while you're simultaneously learning finance concepts yourself. Why? Because you need that knowledge to craft the right SQL queries and pull the data she needs. And here's the twist. This wasn't just an exercise in imagination. This was my reality. Looking back now, with the rise of LLMs, I often wonder, would my life have back then be easier if I had ChatGPT by my side? And if so, would my role have even been necessary? That question sparked a journey. I began exploring whether it was possible to build a system that could take a subject matter expert's request, translate it into SQL, run the SQL query, and then return the results in plain language the expert could actually understand. As I dug into the existing literature, I came across BERT, Big Bench for Large-Scale Database-Grounded Text-to-SQL Evaluation. It's a pioneering cross-domain dataset designed to test how well models can handle text-to-SQL parsing when faced with extensive and complex database contents. In other words, it pushes beyond toy datasets and looks at how models cope with a kind of messy, real-world databases businesses actually use. While exploring the BERT benchmark, I came across a paper currently ranked second on their leaderboard: Automatic Metadata Extraction for Text-to-SQL. The authors point out that the hardest part of writing SQL queries isn't the syntax, it's understanding what's actually inside the database. Documentation is often missing, outdated, or incomplete, and even SMEs don't always know the full picture. To address this, they introduce a framework that uses GPT-4o to automatically extract metadata that helps bridge the gap between natural language and SQL. The approach has two components: learning the database domain language, profiling, and metadata generation. It starts by profiling the database, collecting stats about fields like value distributions, formats, distinct contents, and then using the LLM to summarize these profiles into natural descriptions. For instance, instead of a cryptic field name like CDS code, the model can generate a description such as 14-digit numeric identifiers for each school, where CDS stands for County District School. This creates a domain-specific vocabulary that the system can use to interpret user requests. The second step is inference and query generation, schema linking, and SQL synthesis. Once the domain language is established, the system applies schema linking, mapping user questions to the relevant tables and columns using the metadata. Then, GPT-4o is tasked with generating SQL queries, iteratively refining them until the literals and joins match the database contents. This inference pipeline ensures that vague or ambiguous natural language requests can still be resolved into precise SQL queries. If I were to apply this approach to the system I had envisioned, two additional steps would still be needed. The third step would be executing the generated SQL against the database, but only after passing it through a security layer to ensure the query is safe and cannot cause unintended consequences. The fourth step would then to take the raw SQL queries and translate them back into natural language, so that a subject matter expert could easily interpret the output without needing to understand database structures or query syntax. With the infrastructure design, the logical next step was to validate its effectiveness on a practical SaaS application. To do this, I built Lexitao, a platform that processes financial documents and enables natural language queries over structured data. It's sort of an attempt to compete with Xero, the leading SaaS app in New Zealand. But the main difference is it explores a different dimension, bridging the gap between raw financial and accessible insights. So, let me show you a demo of the application. This is Lexitao in action. The goal is simple. Take raw financial documents and turn them into plain English answers. No SQL needed. I'll start by uploading an invoice. The system automatically detects the document type, either it's an invoice or a receipt, by analyzing both the text and layout. That way, it routes the file to the right extraction model. Here's the real magic. Instead of writing SQL, our finance expert just asks, what were my top 5 vendors by total amount last quarter? Show expenses by category for the last 90 days. Behind the scenes, the system links the request to the right tables, generates SQL safely, runs it, and then explains the result in plain English. No database knowledge required. And if you ask something the database can't support, the system doesn't make up an answer. Instead, it flags the issue and tells you that no valid SQL could be generated. This is how we stop hallucinations. The model won't invent data that doesn't exist.